Okay, just looking at some notation and wording. The exam board do like changing, making the wording slightly different to mean exactly the same thing. So we've seen f dash x dy by dx, Newton notation, Leibniz notation. The other way they'll ask you is they'll say what's the derivative, or they'll say what's the gradient, or they'll say what's the rate of change. The exam could use any of these to mean exactly the same thing. So if we've got our f of t, it's f dash t. We've seen y is dy by dx. If it's c equals something p, it's going to be, rather than x and y, or y and x here, we've got c and p, so it's dc by dp. So change in c over change in p, as it were. So look at this first one. F of x equals x to the 4. Find f dashed of 2. So basically what it's saying is find the value of the derivative at x equals 2. So we differentiate as we've been previously doing. Power down, multiply, reduce the power by 1. So we get 4x cubed. So what we do is we swap the x for a 2. So f dashed of 2 is 4 lots of 2 cubed. So 2 cubed is 8 times 4, 32. Next way it might ask it is find the rate of change of 6x to the third at x equals 8. So it's a function of x, so f of x equals 6x to the third. So f dashed x, power down, a third of 6 is 2. X to the negative 2/3, which is 2 over the cube root of x squared. Because we're subbing in a number, it's much easier to sub it in, especially these will be on the non-calculator paper. So f dashed of 8 is 2 over the cube root of 8 squared. The cube root of 8 is 2. 2 squared is 4, so it's 2 over 4, which is a half. So y equals 2x minus 3, x plus 2. Find dy by dx at x equals negative 1. So first thing we need to do, we need to put it in differentiable form, so we need to multiply out the bracket. So 2x squared plus x minus 6. So that's going to be 4x plus 1. The 6, remember, negative 6 disappears. X becomes, because it's 1x, it just becomes 1. So at x equals negative 2, 4 lots of negative 1 is negative 4. Add 1 is negative 3. I apologise for the noise in the background, it's my cat. So this one, h of p, thought I'd change it up a bit and have a different function notation and a different variable. So p minus 1 over p squared, find h dashed of a half. So separate it into its individual parts, so we get it into differentiable form. So it's p to the negative 1 minus p to the negative 2. So h dashed p is negative p to the negative 2 plus 2p to the negative 3. So it's 2p, all I've done is swap them round, so it's 2p, 2 over p cubed minus 1 over p squared. So h dashed of a half, so 2 over a half cubed minus 1 over a half squared. A half cubed is an eighth, a half times a half times a half. A half squared is a quarter, half times a half. Because we're dividing by a fraction, we flip it and multiply. So it's 2 times 8, which is 16, minus 1 times 4. So 16 minus 4 is 12.